Just one little example. This is a little piece of the placenta. Placenta is about this big around, yay thick in the middle. And if you look at a placenta after it's been delivered as afterbirth, there's like lumps on the surface that were up against the endometrium, the uterus. And those little lumps are like looking at the tops of trees in a forest. There's approximately 20 little trees, they're called cotyledons, in a placenta. Each one has one trunk, and then they branch, and the branches have branches, and the branches have branches, all the way out to the twigs. This is one of the twigs. And you know, trees have bark. Well, a placenta has a coating of a cell here that you see this little red line around here. Notice the nuclei are puddled together. I can tell you something amazing about this, something you probably don't know. It may be your obstetrician doesn't even know this. The whole surface of the placenta is one cell. It's called syncytial trophoblast. It has millions, perhaps trillions of nuclei, but it's all one cell. That means you're not getting across this barrier here unless you go right through the cell. There's no way to sneak through between cells because the whole surface is one cell. It formed from the fusion of many separate cells called cytotrophoblast. Now, here's where you see God's handiwork. The red blood cells inside the twig, see these here, and there's a white blood cell here. These are the baby's blood cells. They're completely separated by this seamless one-cell border, which, by the way, if you could flatten this cell out, it would occupy the area of a living room area rug, about 8 by 11 feet. That's a big cell. Here, this red blood cell is mother's red blood cell. So baby here, mother here. That makes sense? Got the barrier in between? Now, the baby has to make its own blood. That's one thing the placenta can't do. The placenta serves the function of the lung, the kidney, the GI tract, the endocrine system. I mean, a baby can be born without lungs and survive till you take the placenta away. It's just one marvelous organ, but it doesn't make blood for the baby. Baby has to make its own blood. How long is it going to live without blood? No time at all. What does a baby need to make blood? It needs to make hemoglobin, just for one. Hemoglobin contains iron, and its only source of iron is from mother's blood. Boy, have I got some bad news for you. Iron does not go across the placental barrier. It's impermeable to iron. Anyone see a problem here? Life's over. One generation, that'll be the end of placental mammals. The next generation won't be born because they can't make blood. By an incredible stroke of dumb luck, one of the 100,000 different proteins in our body belongs to a class of about 200 different proteins, averaging about 400 amino acids apiece. And one of them is called transferrin. Probably never heard of it, but you wouldn't be here without it. Transferrin goes across this barrier, picks up the iron from the mother, and is able to carry it across the barrier and release it to the baby's blood, without which end of the life. I've got a question for you. How many million years are you going to have to get this right? Now, here's a challenge to evolutionists. Out of 100,000 proteins in the body, I just want one. Transferrin. I'm going to put that in my pocket right here. I got it. You don't get it. But I give the evolutionists everything else on Earth. Boy, that's generous. Everything in the universe, all living things, I give them that as a head start. Wow, how generous can you be? I'm only holding back transferrin. They're done. You don't have a million years to get transferrin. You need it now. You need it for the next generation.